Hello there, it's Alana Tucky, and I'm going to show you in this video how to use your calculator to find values for the normal distribution, namely how to find areas under the curve, areas, probabilities, percentages, all that good stuff. That's using normal CDF, and then how to reverse that process and use inverse norm. Okay, so let's start with the first problems, which is I'm giving you the mean, the standard deviation, and an x value of 90. And what I want to know is the probability that x is greater than 90. So I'm giving you the score of 90 and I want this area over here. So to do that, you're going to need normal CDF. So normal CDF takes the lower bound, the upper bound, the mean, and the standard deviation. So the lower bound of the edge we shaded was 90. The upper bound, and now here's where it gets tricky, it's forever, right? Because the normal curve never ends. The x-axis is a horizontal asymptote. So what we really want to say is infinity, positive infinity, but positive infinity doesn't exist. So we're going to use 1e99 right there, right from your scientific notation definition back in an algebra class somewhere, where the e is above your comma button. I'll show you that in a second. And then you're going to tell it the mean, which was 75, 8. All right, so let me show you that. So I want to go to distributions because this is the normal distribution. And we will never use PDF in this course. We're only going to use CDF, cumulative. So we're trying to accumulate. All right, then I wanted, what was my first number? 90. So my lower bound is 90. So you type lower bound 90. Upper bound 1e, which is second, comma, and then 99. Then your mean was, I don't remember, 75, I think. 75 and then 8. So you type 75, enter, 8, enter. Then go down to paste, enter, then hit enter. And you can see old school calculators, this is what you have to type. You literally have to type 90, 1e99, and so on. The new calculators, you have that menu that kind of sets it up for you. And so it's 0.0304. And there you go. Okay. All right, so everything else is just kind of variations on the theme. Like this one is the same idea, but it's a left tail that they're giving you. So you're going to want the area in the left tail. All right, so how does that work? Well, the far left edge of what we shade is negative infinity, but we don't have a negative infinity button. So we're going to do negative 1e99, comma, 25, comma, 30, comma 4 on this one. So let's go back. Second distribution, number 2, normal distribution. So it's negative, oopsie, not minus, clear, negative 1e99. Upper bound was where the edge is ending, so 25, 34, enter, and then press enter. 0.1056. Oops, I got an extra 0 in there. All right. Now what about a between probability? Well, actually that's easier. A between probability, because it gives you two edges, actually you don't have to bother with the whole 1e99 business. The 1e99 business is what you need when you have a tail, when you have a tail shaded, because you're going off to forever here on the left. But we don't have a tail shaded, so I'm going to go 19, comma, 23.5, comma, 20, comma 2. Let me type that in. Distribution, number 2, normal CDF. So it's 19, 23.5, I don't remember, 20, comma 2. So 20 and 2. Paste. Enter. 0.6514. There we go. 0.6514. All right, last but not least, what if we want to do this this one? So I have the left tail over here, the right tail over here. I could find each one of them individually, but that'd be kind of a pain. What I could do is find the white gooey center in the middle, right? Like the Oreos. Right, so I'm going to take normal CDF, and it's 165, comma, what's the high number? 200, 200, and then the mean was 180 and 12. So 180 and 12, paste, enter. 0.8466. All right, so let me type that up. So we're finding the center. So let me write that in. Hold on one sec. There we go. So the center is normal CDF 165, 200, 180, 12, and that came out to be 0.8466. 8466. And then we'll take it away from 1 for the tails. So the tails is 1 minus the center, which is 1 minus 0.8466, which is 0.1534. Like that. Oopsie. There we go. Just trying to underline it. Alrighty, that's how to use the calculator to do normal CDF for a whole bunch of different things. Tails, center, the whole gamut. Okay, so now what about the opposite? What about inverse norm? So let me find that for you, which is right down here. Got it. So we have an x value that cuts off the bottom 33% of the curve, right? So then how do we find it? Well, inverse norm is when I give you the area and I'm asking for a score or a value, right? In this case, I'm asking for the x value. So let me do this. You want inverse norm, but inverse norm only takes 3 things. It takes the left tail area, then it takes the mean, then it takes the standard deviation, which I think I have right here. Yep. Inverse norm, left tail area, mean, standard deviation. Okay, so how's that going to look for us? Inverse norm, the left tail area, that's this part down here, but it says it's the bottom 33% right there. So that's 33%. So 0.33, comma, the mean is 75, standard deviation is 8. And you just press that into the calculator and you'll have it. So let me clear this out. Distribution, and it's number 3 right there. See number 3, inverse norm. You say 0.33, comma, and then what was it? Oops. Hold on, I'm in the wrong spot. There it is, 75, comma 8. 75, enter, 8, enter. 71.48. Okay. Oops, that's the wrong video. Come back. 71.48. Alright, so that's one where I gave you the left tail already in the problem. Let me see if I can go find some others. Let's just move on to the next problem and that'll have some for us. Okay, so Columbia, the GRE tests are tests that are sort of like the SATs, but they're for graduate students. Like if you want to get into graduate university, you have to take this big test. And they have a mean of 1066 and a standard deviation of 191. Columbia only wants the top test takers, the top 10%, because Columbia is Ivy League, so they're snobby like that. So how would we do this? You take inverse norm, but here's the kicker. It only will do the left tail area. So I have this red shaded region, but that red shaded region is worth 0.10, 10%, the top 10%. So I need the left tail area, which is 0.90, because together they've got to make 1. And then 1066, 191, and you'll have it. So you go inverse norm, number 3, there we go. And then you say 0.9, 1066, 191, paste, enter. And there it is. They'll only look at you if you have a score over 1311. Right? It's technically 1310.7, but that's impossible on a test like that, so we'd round it. All right. 25th percentile is basically the same as the one up here, right? It's 25% instead of 33%. What about this, though? This is a really important problem for later on in the course. So how would this work? So if you got the middle is 95%, let me make that bigger. The middle is 95%, that's the white region in the middle. Then each tail is worth 2.5%, right? Because you take, let me write it out. Oh, goodness. I'm just having problems all over the place. 1 minus 0.95 is equal to 0.05. That's both tails, right? So then each tail is 0.05 divided by 2, which would be 0.025. All right, so each tail is 0.025. I gotta make this smaller so we can see it on the screen. There it is. Okay, so each tail is 0.025. So how are we going to find that? So we take inverse norm 0.025, comma 1066, comma 191, and this will be the one on the left. So this will be left-hand score. Okay, so if I type that, actually I could just do second enter. Well, I'll show you again. Distribution, number 3, there it is. So I want 0.025. Enter, 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 enter. 691.6. So that's 691.6, which would be 692 in this case because you can't score 0.6 on an exam like that. The right-hand score would be inverse norm of 0.975, 1066, comma 191. Let's see. Now I'll show you where the 975 comes in a second, but let me find this. So number 3, inverse norm, enter, 0.975, 1066, 191, enter, 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 and you get 1440.3. So 0.3, which is 1440. Now the real thing is, everybody always gets confused about, is where did the 975 come from? Well, this little red tail over here on the left is 0.025. Now remember, the entire white middle is 0.95, right? So if you're over here at 1440, what's to the left of that? Because that's what you need. You need left area on in an inverse norm function. So you need the area to the left of 1440. Well, there's 95% in the middle and 2.5% over here. 95% plus 2.5% makes 97.5%. Or you can think of it this way. The whole curve makes 1, right? This little bit over here on the right is 0.025. So everything else is 1 minus 0.025, i.e. 0.975. Notice that these two numbers right here and right here add up to 1, right? Because you have the entire curve covered. So one of them is this little left tail right here, and then the other one, this 975, is that little left tail plus all that white region in the middle. All right, so that's how to use the calculator to find inverse norm. I hope that was helpful for you. I'll see you back here for more videos.